Hello all. In this video, we are going to do the Bangalore house price data analysis using R. In the previous video, we did the same analysis with Python. Now, if we do using R, we will get a sense of both language, how both language works, and some of the subtle difference in the language. So first, I will call data set e.csv. So let me just go and copy the name of the data set, and let me just call header equal to true. So now you can see the data has come here. So it has 13,320 observation and 9 variables. So 9 columns, you can see all of them here. Now, first thing we will do, since we have done quite a few of visualization in Python, we will not spend too much time on the visualization. Can do little bit, but first thing probably what we will try to do, we will see we will try to do some data cleaning. First we have to do some data cleaning. And if you look into the data, you can see in the society there are quite a few empty variables are there, empty cells are there. So we can check how many empty cells are there by calling extracting the society column, equate it to quote unquote, and then take the length of just df society. Okay, so this will give you all the cases where you have quote unquote kind of thing, and then if you just say length, then it will give you 5,502 cases where society value is not available. So you can see it in this way. You can write it down, have a note, you can write it down with a note. In 5,502 instances, the society value is not available. These could be stand alone house, but we don't know. Okay, so the next thing is, so probably we will not use society in our analysis. So we will not use society as we did in Python. We will not use society in our analysis as we did in Python. So I'm not okay. Next is BHK, and you can see most of these BHKs are exactly like either bedroom, sometimes BHK. So we have to handle that. So we have to handle BHK variable. So how we do that? First, let us see how many unique BHK columns are there. It is written as size, I believe. Okay, yeah, size, correct. So these are the BHK things. So now what I will do, as we did in Python, we will create another column called BHK equal to NA first. So now there are 10th column, there will be a 10th column with BHK, all values are NA, just we created a placeholder. Okay, now N equal to N row of DF is the number of row in the data set, 13,320. Okay, so first thing we will do is, let us take the first case. It is 2 quote unquote BHK, right? Now what I'm going to do, I'm going to call a function called string split. Okay, it split the elements of a character vector. Okay, so what it will do is string split 1. Okay, let me just first run this. Oh, I have to give like by what they would split. So now you can see so that this was my original DF size 2 BHK. Now they split it into 2 and BHK. So now, but they have kept it as a list. So we have to put it as a unlist. We have to put it as a unlist. Okay, now if you just put it as a unlist, so the first element is 2, next element is BHK. Now what I'm going to do, and then if we just put say 1, then it will give me the first element, which is 2. So now what I'm going to do, I'm going to run it through this line basically over the all cases 1 each to n unlist, and this will be like df $BHK on the ith cell, and this will be an ith component. So let us run this thing. It's done. Now if I just go there, you see it's filled up. But remember that when it was done, it was character. So if I just check the structure of the data set df, you will see BHK is kind of used as a is being stored as a character. Okay, so now what I'm going to do, df as a df $BHK as dot numeric df $BHK. I think no problem. Now if I just run this, now you can see BHK is numeric, no problem. Okay, all right. Next we have to, let us look into the data set. So BHK now size was split and put it into 2, and the size of the number numeric, it was converted into numeric. Now we have to look into the total square feet now, because if you can see, total square feet are considered as a character variable. So because there were lot of dash sign or very weird way of stored values were done. For example, this one 3010 or 2100 to 2850, this 31st row. Okay, the 31st row, they have done it in a very characteristic or string way of storing the data. Okay, so if you look into the df $total square feet 31. If you look into this, it's a very string way of doing data. So what we can do, we can just say okay, string split df dollar total square feet. Okay, I have to give, obviously I have to give a say dash, right? Of course not, this is, I have to say 31, sorry about that. So this is my df 31, and then if I string split, so by the dash it was splitted. The first element was 2100 and the second element was 2850, but both are character and it included some space and it was kept in string. So let us put it in some dummy variable. Okay, so let us put it in some dummy variable, and then first let's unlist the dummy variable. Unlist the dummy variable. Now it has the two element as a vector, but both of them have some white space added to it. So what we will do, we will just trim the white space. Okay, we will trim white space. Okay, so you can question mark trim white space. Yeah, you see, remove leading or trailing white space, that's called trim ws. So now if you run it, you can see that the white space are removed and it's just one single element. Now what we can do is we can convert it to numeric. Okay, and then we can take the mean of the two. $2,475 is the number. And then what we can do, we can just do the same operation over all I, because for example this is the one, and then if I just run it through say 30, it is 1025. Now if I run it through in this is perfectly fine. I just convert it to numeric, that should be fine. But if I just, even if I run it through this process, then it's just still 1025 square feet. So I can run this operation through the entire thing. Okay, for I in 1h2 n. So let me just copy this and paste it, and okay, I don't need this guy, I just need to put I here, and then at the finally df total square feet I, you just put this dummy variable, and then you are done essentially. So let me run this operation. There are 46 warnings, but you can see that now more or less there are no much. So those 31 is 2475.754. So now most of the cases are being taken care of. No dash business are there. So that's a big problem solving. But still, if you look into the structure of the df, I think I have to just check whether it's still total character. So what we have to do, we have to say, okay boss, we need to put as dot numeric. All right, and now we can see probably they have indeed gone into as dot numeric. Okay, so total square feet is now numeric. So this is a big problem solving. Next we have to handle the location. Okay, so location is very important, and we have to handle the location. Why? Because there are quite a few locations where the number of instances were very few. So how to handle it? df dollar location, and first what we can do, we can just say table. So it will give me a table of each location, how many instances are there. So if I just say sum, it will give me 13,320. you see, but I don't want it. I want the table and each locations are there, and then I can just sort them. And let me put it in some variable or some object, loctn location. Okay, and so if you just say head of loctn, then it will be like first few, maybe 10. These are all places where you have only one instance. These are the cases where you have only single instances, and there are one instances where you have no space, like location is not known, so you just have some quote unquote kind of thing. So what we can do, wherever the location belongs to this, say Ankela, Anekkal, or any one Girinagar or something, the location is less than say 10 or 20 or 15, some number we consider it, or say 20, let's take 20, then we will consider it as that we don't have enough instances. In those cases we will put it into others. Okay, so how can we do that? So let's take one particular location, say 3. Okay, on the third case is Uttar Halli. Now in the location, so this is the name of the case, in the location table, if I just put that guy 186, that means out of 13,320 cases, instances, there are 186 house which belongs to the location Uttara Halli. Okay, now if what we will try to do, we will try to say that good boss, if this location is say less than 20, then we will say this location as others. Okay, this is something what we will want to do, but we don't want to do it here. We will do it in a little bit more fashionable way. We have to also take care of one problem, that there is a one quote unquote thing is there. So and how location table is handling this guy. So if I just say df location, if I just say df location equal to quote unquote and df dollar location, okay, so there is one case. Now if I just put it there, then it's a NA, that means, and we have to, that means handle NA inside the if condition, and that could be a bit of a challenge. So there will be one NA that we will we will encounter. So let us try to handle it. For I in 1 each to n, first thing what we will do, we will take the location of the ith instances and put it into the location table, and we will see what is the count. Give me the count, and that count I will put it as a dumb variable. So either it will give me NA or it will give me some number. Okay, so if dumb variable is dot NA, then we will say, okay boss, in this particular case you just put others. Else if dumb variable is less than 20, that means the number of instances in the entire data set for that particular location is less than 20, then also you put it others. Else you just leave it there, you don't worry. Okay, so if I just run it, it runs very fast, and you see if there any others have come. There may be one or something. Okay, we will see. So at least I think the location thing is now kind of okay. Most of the data cleaning thing has been done. Now we will do the model training. So let's split the data in train and test. Split the data into train and test. Okay, split the data into train and test. Now, so the first thing I will do, m equal to ceiling and each to 0.7. okay, so that will give me, so out of 13,320, 9,324 instances we will take as a test data set, training data set. We will take it randomly, and rest we will take it as a test data set. So we have to first set the SID. So how we'll do that? So typically the way we do it, I do it is 1 each to say 10,000. I just draw one sample, all I need 7526, and that I will set up as a SID. Then what I'm going to do, I'm going to draw sample from 1 each to n, m many sample, and replace equal to false, and then I must do it's a one-time sort, don't worry about that, one-time sort is fine, and I just do id x. So these are the IDs I'm going to draw, and if you use the same seed you will get the same data set, same split, exactly my result and your result will be same. So df train will be df with these IDs, comma, so these are the row values and column values, all columns will come in, and df test will be minus of these idx. So now this is df train, okay, and this is df test, okay. All right, next what I'm going to do is we are going to fit our first model mod 1 LM price. Let me just get the call names of the df. So price, so that we don't make spelling mistake. Price total square feet plus area type plus balcony plus and BHK plus your bathroom. I think we have to take bathroom. Sometimes there are bathroom and then BHK there are, yeah. So we can take bathroom instead of bathroom BHK and data equal to df train. Okay, and at the end you just say summary of mod 1. Remember, note that I did not put location yet. Okay, I did not put location yet. So if you see, I just put area total square feet does have a strong correlation, strong effect, very strong effect. T value is 58, P value is very small. Area type, plot type area has quite significant effect. Plot area, the things which are plot area, they have a very little bit premium price people are paying. If bath is number of bathroom increases, then the premium or the price goes up. But if the number of BHK increases, it looks like it's a negative. This is bit worry. I don't know why it is negative. And adjusted R square we got 0.4251 with no location. So now if we add a location, if we want to add location, so mod 2 equal to what we will do, update the model 1. You update model 1. How you do that? Dot comma dot plus you just put the location. Okay, so what is the call names of df? So this is the location, so you just put location and it should work. All right, and then let's see summary mod 2 of location, and you can see that adjusted R square now went up to 0.629, right? Okay. See, Ashok Nagar has very strong positive premium, looks like Ashok Nagar. Okay. Eighth block Jayanagar, fifth block Jayanagar, 4-bedroom house in Bangalore. Okay, then these are the, in some of the locations still required, I think still the bedroom things, 7th block, 6th block, this 4-bedroom farmhouse in Bangalore. Okay, they have put the bedroom information in the location. which is not right. Second stage arithmetic. Okay. So, all right. I think there are a lot of things are being missed. Actually, lot of areas are being missed. But adjusted R square has now 0.629, which is similar to that of Python. Now, what I'm going to do is very simple. That I'm going to check some price, like test data. Okay, test data. I'm going to create some df test 1. So this is df test data. Now this test data is a test point that we are going to try out. The location we are going to use, say first Rajaji Nagar. I remember in Rajaji Nagar case we got a value of near about 200 lakhs or 2.4 crores, something like that. Let's see in this time what happens, what is the situation. So now we have changed, it was Uttarahalli, but now in the test data we have given a location Rajaji Nagar, and the total square feet will be total square feet will be say 1000 square feet. Okay, and then bathroom will be, there will be 2 bathroom, and it will be 2 BHK. It will be 2 BHK. So let us run this through, and now if I just predict mod 2 with new data equal to test data 220.45, so it gives me a price of 220 lakh rupees. So that means 2.2 crore. In Python it was giving me 2.4 crore. So it is somewhat in the same range. Remember that we also had made a model 1, initial model, base model. What happens if we use model 1? And model 1 had a very low R square, 45%. In model 1 it is giving me 52 lakh. So model 1 looks like giving me a not so good. Also model accuracy for model 1 is adjusted R square is very low compared to at least 20% lower than model 2. So location is very important. Location, if you based on the location the house price vary extremely. Okay, now one thing we can do is we can look into the train data set. Okay, in the train data set, among the df train location equal to Rajaji Nagar, and we can look into the price. So these are the instances which are the houses which belongs to the Rajaji Nagar and their prices. Now if I take the mean price or median price, so the median price is near about 250 and mean price average price is 320. So given this, I think predicted model is giving 220, I think is a decent correct value probably, and we can try few other models. For example, we have not tried log linear model, so we can try log linear model. So let us try that. So what we can do, we can just take the model 1 and this will be the third model, and we are trying log of price, right? Log of price and log of total square feet. So this will be log of bathroom. I'm giving 1 because in case there is 0 bathroom, it should not happen. Achha, let me not take. If there is 0, then it will throw error. But let us take this just for fun. Let's see how this turns. Okay, I have to put location also, plus location. Okay, so it will take little time because it will create all the dummy variables and then it will fit the model. All right, summary mod 3. So now after log return, it has gone up to 85%. Okay, so this is a huge jump, another 20% just because I am getting, but that may not be a correct thing, because remember that these are in the log scale. Log scale, it is linear, it is becoming linear, and that's why. And in the log bath and log BHK, they are all now positive and everything is now pretty cool actually. So maybe it will give us a much better accuracy. So what I will do, I will just take this thing and we can just use this model 3 to predict the same data set. So test data is still that same Rajaji Nagar with 100 square feet and 2 bathroom and 2 BHK, but now it will give me in log scale. The price will be in log scale, so I have to put it in e to the power. Remember that I have to put it in e to the power. So it is now giving me 107. Okay, so I don't know how good or how bad it is. So this is looks like this could model looks good, but it is looks like slightly giving me undervalue. Now is it a right model? So best way to check it out, what will be the test cases in the test data frame, what would be the predicted price. So test df test dollar price hat. What I will do, I will just put the test hat 1. Okay, predict 1 df test. Here instead of that, I'll just put df test, and then df test 2, that will be model 2. Okay, there is some error it's throwing because in the second test model it's saying as new level. Okay, that's this is bit of a problem always I have found when you have too many so basically what is happening, the issue is, I'll tell you, if there are cases where the test dataset has some values which are not there in the trained dataset. So when the split happened, the split was not correctly, has not considered everybody in from the thing. So one way of doing it is from each test area, we can split it in train and test. So that is one way of definitely one way of doing it. That will be a, yeah, then that's a good idea actually. Let me try that. Yeah, so this splitting, what is happening, let me repeat the problem. Okay, please pause your video, you may take a break, come back, but let me tell you this problem. I face this problem often time, but let me tell you this problem. In the location, there are too many locations. In fact, we can look into the location. There are df dollar location, and if I just say unique length, okay, length, there are 1306 unique location. Now when I'm splitting the data, I'm randomly splitting, and quite a few of them, few locations, all samples of locations have gone into the test. So that means those locations are completely missing in the training data set. So for those locations, the training data set did not able to train, and as a result, now it is throwing that, oh, in the test data set there are, because if you look into what it is saying, it's saying that model data frame default error in model factors location has new level. The test data set has new levels which is not available in the training data set. So that is what it's talking about. So we have to split the data in so way that all 1306 location will split into 70-30 way. Then each location will have a representative of samples in their training data set. Okay, you understand? So let us try to make this thing. It is going to be a bit of a, let me try this. Let us try this. Okay, now so first is location names equal to, what I will do, I will just take this guy and put it there. So here I have all the names. I will just put it in there. Okay, and then what I'm going to do is, for it is going to be a bit of a challenge, df train equal to df1 and kind of df test equal to df1. We will just later put it as a drop this first row, just to, I just need a data structure, a framework. Okay, so if I have just the framework, the structure. So if you just see, I have some structure. Later I will keep appending on that. So that's my idea, and later I will just drop the first row from both frame. Now what I'm going to do, I'm going to say that, okay, df sub df equal to df dollar location equal to location names, comma. So if I just do that, so these are the cases where you have bunch of names, say electronic face. Let me just call it df sub. Okay, so let me just put it in df sub. So what is that? 132 observations. So these are the instances. There are 132 observations which all belongs to electronic city phase 2, this location. Now I have to split this guy into 2. So what I'm going to do, n1 equal to n row of df sub, df sub, and then what I'm going to do is m1 is equal to ceiling n1 times 0.7, and then idx equal to 1 sort sample 1 h2n n1 comma m1 replace equals to false. All right, so this is what I'm going to do, and then df train is equal to df sub rbind dot data dot frame and df train comma df sub with idx that we have here. Okay, so if I just now do that, so now you have df train as this. So the first thing, and then okay, and then similarly df test equal to df test and minus of that is going to give me the all test data set, that half of 40 out of 94 of them goes to, or 93 of them goes to train data set, and 39 of them goes to test data set. Okay, all right, so m1 is 93 and n1 minus m1 is 39, so 39 goes to, so that's why it is 39 plus 140 and it is 93 plus 140, because we have one row added first, so we will drop that later. So now whole thing I'm going to repeat in a row for loop for I in 1 h2 length of ngth length of location names. Okay, and this is going to be the I. All right, and you have df train and test here, and I just need a set dot set here. Remember that this method is okay. Now you have train is this many and test is this many, and what I will do, I'll just send df train equal to df train minus 1. So I have 9,921. Now it is 9,920, because remember that the first row I want to drop, right? I want to drop the first row, and similarly df test I want to drop the first row. So now my things are ready. So let me now run the model. Let me just copy this model and run it here. Okay. So this is 46%, about 46% accuracy. Total square feet. BHK is negative, which is a bit of a, I don't know, this model has some problem. And then we go and try to fit model 2. Okay. It will take a little bit time because it will create all the dummy variables. Now it has 63.8% accuracy. 63.8% accuracy, and Ashoknagar has a very high p-value. Jayanagar, Koramangala has a very high p-value. Alright, so we will see what is happening here. Okay, and then finally we will take the third model and we will see what is happening here. So in the third model, it is giving us accuracy up to 82%, but these are in sample accuracy. Remember that. So you have to be a bit careful about these kind of accuracies. So if you run, so first we have to check out of the sample accuracy. So let me just copy these two lines and paste it here. Okay. And similarly, if I just see, now there is no problem. Now there is no problem, and it gives us the exact accuracy thing we wish it. And then this is the third model. And if we just look into the test, so we have price hat from first model, second model, and the third model. Okay, so the third model looks like it's a little bit maybe it's not that great model, I don't know, some issue is there. Oh, it's all same places. Maybe we will see what is happening there. Oh, not def test data, we want df test. We want df test to be there. Df test, there was a mistake. Now it is doing well. All right, now what I'm going to do, if you look into this particular case, the price is 150. Price hat, the first model predicted 251, second model predicted 220, and third model predicted 138. So this, from this one case, looks like the third model has done good job, but we have to first compute the root mean square error. So what we will do, we will take the df test price 1 hat minus df test dollar price, square it, mean it, take a mean of that, take square root of that. So okay, I have to take NA dot RM equal to 2. Some places probably did not able to. So this is my RMSE 1 out of the sample RMSE 1. This is out sample, remember that. So this is my out sample RMSE, and second is from the second model. This is little less, and the third one is from the third model. Okay, and this is way less. So third model is not only doing well, it is doing pretty well to great extent. So log, that means basically the total square feet, bathroom, BHK and price, they all have a log linear relationship, and that is why even in the out of the sample they are doing far superior than the just simple linear regression. Okay, and we can also compute the correlation between the two. We can just take core complete, yeah, and if you just take square, so this is really less, and then if you just take 42%, and then 3, this is approximate R square is 62% out of the sample approximate R square. These are like out of the sample approximate R square. So it shows that third model has pretty good predictive power, and even out of the sample it can predict the price with 62% variability can be explained, which is very good. Some out of overfitting is happening, but that can be handled. So with that, I will stop here. I hope you enjoyed this hands-on session. So see you in the next video. Thank you.